The whole idea is that we have a nice program. We have about 5 presentations. The presenters can take over the screen when they want and go through the slides themselves. It's a Teams link, meaning you have full accessibility to all the buttons. So please mute yourself during the presentations, but after every presentation, I will allow some time to ask questions. So you can unmute and put your camera on and ask your question, but you can also put questions in the chat during the presentation. As mentioned, everything will be shared afterwards via the normal channels that will be explained later. So maybe first of all, my name, Carlo Mol, just to say one sentence about me. I work at Vito in Belgium. Vito is a research institute. We do a lot of things, but my team is mainly focused on batteries. We do a lot of battery modeling, battery testing, so performance testing, safety testing. We work very close with fire departments on fire safety aspects. And doing that research, that triggered me to set up Task49, in fact, within the IEA, to share information worldwide on fire safety aspects of batteries. I think it's a very hot topic, and I'm always happy that we can have workshops and share experiences between a worldwide audience. In fact, I will try to see if my slides are working. In fact, I noticed that today is in fact the World Day for Safety and Health. It's by accident. The main theme of today is more psychosocial, a healthy psychosocial working environment. But maybe if we avoid battery fires, it can help you also with your stress level in your daily job. So it fits a bit in the topic. We put together, to my opinion, an interesting topic. As said, Task49 is about EV fire safety. It's a broad topic. We talk about many different types of vehicles in this task, but today we will focus in detail on light electric vehicles. So the scope is electric steps, bikes, the fat bikes up to scooter level. And we will discuss topics like how do we bring these products on the market? What are the technical regulations about that? Once they are on the market, how do we deal with incidents if incidents occur? So we have a whole list of speakers on this topic. Before I give the speakers the floor to go in detail, I will take quickly 10 minutes for myself to introduce a bit Task49, a bit more in detail for the ones that don't know it yet. I will run through it very quick. You can look at the recordings from the previous workshops where I explained a bit more in depth. But for the newcomers, maybe a few words on IEA EV TCP, many abbreviations. So in fact, IEA, everybody knows, I think, the International Energy Agency. They have a lot of technology collaboration programs on many different topics. And one of the topics is electric vehicles. And within this group, many countries come together and share information and experiences on the introduction of electric vehicles. It can be policy information, it can be technological information, innovation, research. It's quite broad in that sense. You can see which countries are member of the IEA EV TCP itself. You see also the topics where we work on. It's all type of electric vehicles. It's not only the light electric vehicles, which we discussed today, but also passenger cars, the more heavy duty vehicles, trucks, buses, and also maritime. We also discuss charging infrastructure, all the different types that are available on the market. And we have some supporting analysis tasks, looking at life cycle assessments, reuse of batteries, for instance, but also one on EV fire safety. The EV fire safety one is the one I want to explain a bit more in detail. I initiated this already in 2023, and we try to bring together knowledge on the topic of EV fire safety. The whole idea is to collect objective information, because if we read the media and the press, a lot of things are always caused by the EV and the battery. Of course, it's technology which has some specific risks sometimes if it's involved in a fire, but we can also show that statistics prove that the batteries are not always the cause, definitely not. And most products on the market are quite safe, but still then we need to see how do we handle if there is an incident, how do we handle that? Today we will have a few presentations on that. Very brief, yeah, I'm happy with the number of countries that joined my task. We are with 18 member countries, which is a big group. It's an international group, a lot of European countries, but also US, Canada, China, South Korea. So it's worldwide input that we collect. We collect a lot of info, we share a lot of info, and the workshops as we have today is one of the examples of how we disseminate some of the collected info. It's open for everybody, so everybody with interest can listen to the workshops. This is an important slide. These are the workshops that we did in the past. I will share the slides later. These are the links to the recordings and the full presentations. We did a workshop on the impact of electric vehicles on underground parking regulation. We did a workshop on EV fire statistics, and we also did a workshop on emergency response procedures. If you're interested in one of these topics, you can have a look at the recordings later. These are some slides on the agenda, but I will skip these for today, because today the main topic is light electric vehicles. As mentioned, we want to talk a lot about the electric steps, bikes, and scooters. Do they have specific risks when we bring them on the market? Yeah, how are they being tested before they come on the market? And for that, I asked the first speaker of today, Annick Ruting from LEVA EU, to give a presentation on the technical laws and the regulations linked to battery fire safety of light electric vehicles. LEVA EU is in fact the association which groups together all the light electric vehicle producers in Europe. They collect a lot of info on these testing standards, and they are the voice of the community, let's say. And it's my pleasure to announce Annick today to give a first presentation on the technical laws and the regulations. I see many names in the group. I'm not sure, Annick. Yeah, I see you popping up. You're there. So feel free to take over the screen so you can use your own slide set to go forward. So the floor is yours.
Thank you, Carlo. I'm going to try to find my presentation. Can you see it?
Yes. It's good. Not yet in full screen, but it's visible. So
now?
Yeah. Very good.
Great. All right. Thank you, and thank you for the introduction, Carlo. I am the managing director of LEVA EU. And very briefly about our association, we're the only trade association in Europe to work for light electric vehicles. I will explain to you what that term means for us. We do two things. We try to help the companies in our industry to understand the rules and regulations, because they're becoming quite complicated. And then we also advocate for fair legislation in Europe. We're not very happy with the current legislation, which is linked to motorcycles, mopeds, conventional ones on the one hand, and machines on the other hand. We think that we deserve our own legislation, so we're arguing for a light electric vehicle regulation so that I don't have to go to any meetings anymore of the machinery expert group or the motorcycle working group, but I can go to the light electric vehicle working group instead. We really have a deep belief in the potential of light electric vehicles for making transport more sustainable, thus helping to tackle climate change. Obviously, there's a lot more advantages to light electric vehicles. But anyhow, we think that it is really necessary to work to improve the deployment and uptake of light electric vehicles. This is our scope. I'm getting a bit technical and I apologize, but there's no way around it. We have a lot of vehicles which are in Regulation 168/2013, and that's the technical legislation for the L category in Europe. So the light category, there's also an M category for cars, and then there's also categories for trucks and buses. So we have the L category, and in that regulation, we have electric cargo cycles, electric cycles and cargo cycles with more than 250 watts, up to 25 kilometers an hour, but also speed pedelecs, electric mopeds and scooters, electric motorcycles, and then electric 3 and 4 wheels. L6, for instance, is mopeds with 4 wheels, and L7 are microcars. Some of the vehicles are excluded from the regulation. If you look into Article 2.2 of the law, you will find a whole list of excluded vehicles. This is not a list which the Commission has written at the time with very serious and scientifically based reasons. It was more like we don't want to have to do with these vehicles, so we exclude them. That's the case for electric cycles. I always talk about cycles because we talk about vehicles with 2 or more wheels. So electric cycles with 250 watt maximum continuous rated power up to 25 kilometers an hour. Self-balancing the vehicles. Also, vehicles without seating position are excluded, and this mainly covers for us e-scooters. The vehicles which are excluded from 168/2013 come under the machinery directive to be replaced by the machinery regulation in January next year. And I will try to explain to you what Europe has concocted for these vehicles to ensure safe batteries and to ensure that the batteries do not catch fire, obviously, and cause very bad accidents. It's quite a wide range of measures which have been taken. So I will not talk about firefighting. I don't know anything about that. I will just talk about the legal framework which is in place in Europe to ensure that the batteries which are put on the market for light electric vehicles are safe. And the main legal frameworks here are obviously Regulation 168/2013 and the Machinery Directive regulation. However, there are other pieces of law that apply to light electric vehicles. For the category on the left, there's also electromagnetic compatibility, ROSE, which is on the restriction on the use of certain substances. WE is waste of electrical and electronic equipment. And I can go on a while because there's more and more legislation coming into effect, but it's not relevant for the batteries. And the thing is that if vehicles are under the Machinery Directive, you can obtain compliance through self-certification. You will understand later through my presentation why that is relevant. Regulation 168/2013 is just a framework legislation for the vehicles, and the Commission has written 4 more regulations to detail that framework. The one which is relevant for us is Regulation 3/2014, Vehicle Functional Safety Requirements, because that's where there are some requirements relevant for batteries. Very important for this category of vehicles is that compliance happens through type approval. That means that you have to build a type, and then you have to go to an accredited test house, which will check if all requirements in type approval are met by your type, and then you can start to produce following that type. You can see at the bottom the battery regulation, which is a horizontal regulation, so it applies to all products, including light electric vehicles, whether they are under the Machinery Directive or in Regulation 168/2013. Now, where are the requirements relevant for light electric vehicles? There are some in the Machinery Directive. The Machinery Directive is a piece of law that is also horizontal. applies to all types of machines, and has only essential safety requirements. And in our sector, these essential safety requirements have been translated into European standards, which then have very specific requirements for light electric vehicles and also description of test methods. The EMC directive is not really relevant for the batteries, neither is ROSE. We is applicable to the whole vehicle, so it has to be collected and potentially, possibly recycled. But there you have to remove the battery before you collect the vehicle. And the whole aspect of collecting and recycling batteries is in the battery regulation. And then I already mentioned for the ones under 168/2013, you will find the requirements relevant for batteries under Annex 4 electrical safety requirements. Finally, there is the battery regulation, and the battery regulation has detected 5 categories of batteries. There is a category for light means of transport batteries, and there is one for electric vehicle batteries. Those are the 2 categories which are relevant for our sector. I'm now going to go a bit into detail for the requirements, but I would like to tell you I am not a technical expert. We do have a technical director. He's an electrical engineer. So if you have very specific technical questions, I will collect them and we will answer them after the meeting by email. So please do not hesitate to ask me questions. You will see my email address. You can always contact us for further details. So what does the legislation say for L category vehicles? As I said, they are in Annex 4 of Regulation 3/2014, and this is a very brief overview. The requirements pertain to warning symbols, isolation resistance, overcurrent and thermal protection, state of charge warning, and then secure mounting and non-ejection. So this is what is in Annex 4. These laws are freely available in any European languages, and there are many European languages, freely available on internet under EURLEX, which is the European official journal. For the ones under the Machinery Directive, it's slightly more complicated. As I said, we have drafted, and I'm sorry, I say we because we are actively involved in the standardization process. But we have written standards for different types of vehicles, and there the battery requirements differ from one standard to another. In the EN 5194, that is for electric cycles, electric bicycles, 25 250 watt. This is the only standard which is harmonized under the Machinery Directive. That means if you comply with the standard, you can enjoy presumption of conformity with the Machinery Directive. And there the requirement for batteries is now that they have to comply with EN 50604-1 plus Amendment 1. I will go a little bit more into detail later on this standard. Also, the importance of harmonization is that there is a code called Annex ZA in the standard. And in that Annex ZA, you can see the link between the clauses in the standard and the requirements in the Machinery Directive. So, for instance, electricity supply is covered by Clause 423 in EN 5194. These are the elements which are in the Machinery Directive pertaining to batteries. So electricity supply, fire, explosion, emission of hazardous materials and substances. Then there is an article specifically about batteries, fire extinguishing and emission of hazardous substances. If we move on to 17860, which is a series of standards for electric cargo bikes, the part 5 of this series deals with the electrical aspects. This is for any cargo bike with 2 or more wheels. This is a standard which is not harmonized under the Machinery Directive. So if you comply with the standard, you do not enjoy presumption of conformity. In case of an incident, you will have to prove that your vehicle complied with the Machinery Directive. But there too, the requirement for the batteries is 50604-1 plus A1. Sorry. There we go. So then we move on to 2 older standards. 2022, the standard for EPAC mountain bicycles, not harmonized under the Machinery Directive. And this is a standard which does not yet refer to 50604, sorry, it does, but to an old version of it. But there was no real obligatory requirement. There is only a note in the standard which says that as for the test methods for batteries, testing the battery, for example, according to EN 62133 or EN 50604-1, is considered as sufficient to fulfill this requirement. In the standard for personal light electric vehicles, mainly e-scooters, also not harmonized under the Machinery Directive, there is only reference to 62133-1 and 62133-2. These are standards for batteries, but not specific for batteries for light electric vehicles, whereas 50604 is a standard specifically for batteries. So what caused this change in the standards, moving from quite a liberal referral to IEA 133 or the old version of 50604 to absolute compliance with 50604-1A1, it is the fact that there was an objection from the Dutch government.
Stop it!
Hello?
Oh. No problem,
stop.
Nick.
Do I have to stop?
No. This came from somewhere far away,
Okay.
I think.
All right. Okay.
Please continue. Yeah.
So yeah, there was a changeover to 50604-1 plus A1 because the Dutch government said that the old requirements were not sufficient to guarantee safe batteries, and the main safety risks they identified were fire and explosion, thermal runaway. There were no real requirements for a BMS, and also incomplete cell safety standards. So this is why the EN 15194 has been reviewed. The Commission decided to lift the harmonization for the battery requirements. We then had to go back to the drawing table, and we came up with a new version of EN 15194, where there was a new article for the batteries referring to compliance with EN 50604-1 plus A1. Some additional points of attention for the EN 50604. There is it's actually a standard for all light electric vehicles, and sometimes it's a bit of overkill for very light electric vehicles like e-scooters and electric bicycles. There is a crash test in there, but it's not required if there is a double mechanical lapse or the battery is incorporated in the EPAC. Very importantly, there's currently a systematic review of the standard going on, and the review is going on at international level, no longer at European level. So the EN will become an EN IEC standard when this exercise is finished. Very important to note is that this is a standard about the safety of the batteries, and it does not cover battery regulation requirements. Also important, and this is to do with the harmonization, the Machinery Directive is going to be definitely replaced by the Machinery Regulation in January next year. That means that EN 15194 will lose its harmonization, and there will be a period where there will be no harmonization, but we are reviewing the standard to restore harmonization under the Machinery Regulation. Very important next chapter is the battery regulation, which is European law. That means it applies in the same way in all member states, and companies must comply with the battery regulation as opposed to standards, which are tools to comply with laws. So just for your information, manufacturers do not have a legal duty to apply the standards which I have showed you. These standards have just been developed to help manufacturers to comply with the machinery regulation. I cannot stress enough, battery requirements in the LEF standards are not the same as requirements in the battery regulation, because quite a number of companies think my battery complies with EN 50604-1 Amendment 1. So everything is done and dusted. That is really not the case. The regulation applies since 18 February 2024, and the Commission is now developing further details, which are being introduced with progressive deadlines. The overall aim of the regulation is to establish comprehensive sustainability, safety, and circularity requirements for any battery put on the market. This is a regulation that covers all batteries up to bottom cell batteries. Also ensure compliance, reduce environmental impact from cradle to end of life. That's why they introduce a battery passport. Also to enhance the transparency of the supply chain and the promotion of reuse and recycling. Again, you can obtain the battery regulation from Eurlex on the internet. There are 5 categories, as I already said, but only 2 are of importance to us. There's a category of the light means of transport batteries, which are sealed batteries with a weight of no more than 25 kilograms. And important is that it doesn't matter which vehicle is carrying such a battery. It can be either one in Regulation 168/2013, or it can be vehicles from the Machinery Directive. The decisive factor is the weight. If it weighs more than 25 kilograms, then it becomes an electric vehicle battery category. I will very, very quickly go through the requirements which are already in place. Producers have to register. There are reporting obligations. I've written more details here so that you can, at home, take the time if you're interested to read about it, but I'm not going to sum them all up here. Collection of waste batteries is now also in force. You have to have a technical file for your battery. You have to have a declaration of conformity, instructions for use and safety information. You also have to have mandatory documentation on the performance and durability requirements, and you have to comply with the requirements for state of health and expected lifetime information. You also have to, there also has to be information on prevention and management of waste batteries. And then there's labeling requirements, the CE label. You also need to have a separate collection symbol label to really bin there. And then you cannot use certain hazardous substances such as mercury, cadmium, and lead. In the near future, in August, you'll have to put a label on your battery with general information on the battery, and also a label containing information on battery capacity. And on the menu for next year is that the battery and the battery modules must be readily removable and replaceable and repairable by independent professionals. This is a very contentious requirement. Originally, the Commission put in there that you have to be able to access the battery cells. This has now been changed to battery modules, but it still needs to be ratified by the European Parliament and the Council. Also, in February 2027, you will have to have a QR code that will need to be linked with the battery passport. The battery passport has all the information on the battery from cradle to end of life. And then also in August next year, supply chain due diligence obligations, but there the Commission has decided to limit it to economic operators with more than 150 million turnover. Just for your information, we have a working group for our members where we meet 2 to 3 times a year, where people can ask all questions they have on the battery regulation. If we can't answer it, we do have a number of members who are producing batteries, so they really are quite well versed already on battery regulation. But if we can't answer the question, we can immediately put the question to the European Commission. To finish very, very briefly about battery transport, we are part of Batteries Transport, which is a joint industry initiative aimed at informing companies about the transport requirements. And we provide guidance to our members, but also through this publicly available website. Obviously, there are requirements. Batteries and batteries contained in equipment come under class 9 dangerous goods. And if you go on the website, there are books there which give you the full details on all the requirements, all the tests, and so on. We have an extended version for our members, but there is already an awful lot of information available on the website in the books. So I would really recommend this to you. I don't know, I'm sorry if I have used my time. I don't know if there's time for questions or...
Yeah, so thank you very much, Annick, for the insightful presentation. It's not the easiest topic to explain technical regulations and standards and test norms, but it's clear that you have a very good view as a sector federation on what's going on in the market. I'm always a bit... I'm active already a long time in the electric mobility field, but light electric vehicles, they have so many different product categories and different regulations from different sides that it's always difficult to follow up. But it's good to see that you made this nice overview. I have a few questions myself, but I first want to give also the people in the room the chance to ask questions. If somebody has a question, you can raise your hand and just ask it in the group here. Feel free. If not yet, we are still thinking about it. Maybe I have a few questions myself. Annick, you mentioned something about compliance through self-certification and also compliance through type approval. So these are two completely different trajectories, I guess. It depended on the product category, I think. You fall into a category and then you have to follow type approval, or you can follow self-declaration. Yeah, okay.
Yeah, if your product is under the machinery directive, it's self-certification. If it's L category, regulation 168/2013, it's type approval. This is one of the aberrations in our sector. Nobody has ever asked us, do you think that is the best way to have self-certification for this category and type approval for another category? It has just grown historically. We're not happy with it. We want to change it. We think there should be a dialogue with the sector. What would be the best way? Because, for instance, under the machinery directive, as you know, there's a third way, which is certification with a notified body. So I think at least we deserve being asked for our opinion, what would be the best type of compliance methods for the different types of vehicles. It works very well for the ones under the machinery regulation. There are no structural problems. So we really believe that there's a few vehicle categories in the type approval that don't really require a type approval and would really benefit from self-certification or maybe certification with a notified body. But unfortunately, the law is the law. That's what we have to deal with. But we are knocking on the Commission's door to get a change in this.
You mentioned for the type approval, you need test houses to test the products. I have no idea how many test houses do we have in Europe? Are there many, or is that only a small group?
That's another big issue. There are quite a number of accredited test houses for 168/2013, but not many of them want to deal with light electric vehicles, want to deal, for instance, with the speed pedelec, or with, if you put a seat on an e-scooter, it would also come under type approval. So Belgium has none. Maybe Carlo, if you have some relations, we have been trying already to say we have the largest number of speed pedelec manufacturers, and we have no type approval house here. They're all going to Spain or Germany or France. I think there are certainly not more than 10 test houses which test light electric vehicles.
Yeah. Okay, yeah, that's a point, because we didn't mention numbers because we focused on the technical regulation in this presentation. But if we look at numbers sold about electric cycles and all the others, it's the numbers are crazy. Yeah, we talk a lot about passenger cars and buses and trucks, but yeah, the numbers
it's sometimes difficult to get accurate statistics, but we estimate that every year there's around 10 to 12 million light electric vehicles that are put on the market in Europe. And the biggest categories are electric bikes, 25 to 250 watt. Obviously, in that sector, the manufacturers try to limit to 25 to 250 watt to stay out of type approval. So that's the biggest number. And also e-scooters come in quite large numbers. Other categories are still quite limited. For instance, electric mopeds, motorcycles, also the microcars. Yeah, that also has to do with the type approval, which is not really well adapted to these vehicles. And also, if I may make a political statement, to the choice of the European Commission and European Union for the automotive rather than for light electric vehicles, which is a real pity, because we had a study carried out by DLR a few years ago to calculate the emission saving potential of light electric vehicles, and it was astonishing. The whole range of light electric vehicles could replace 76% of all car trips, and that would result in 44% less CO2 equivalent emissions. So it's just a bit mind-blowing to me that a sector with such potential, and then I'm not talking about the economic potential of the sector, is really being neglected by the European authorities. That has to do, of course, also with the resources of the sector. I mean, we are not ASEA, if I may put it that way.
Yeah, but still the numbers are impressive. And I think in the future, you talked about battery regulation and also circularity and recycling of batteries. I think in the future, we will definitely do a separate workshop on that topic. How do we collect all these batteries in a safe way? How do we recycle them? That will be also one of our future challenges that we have to look at. So
that would be really interesting, because there are now a growing number of companies, new companies, that look into how to tap into that potential by making batteries with recycled material, or reworking batteries, which is very good for sustainability as well, that we just don't throw everything away. Also from that perspective, light electric vehicles are much more sustainable than the batteries of big vehicles.
Yeah. Okay. So thanks for all the information in the chat. I saw that Arundi also dropped a test facility in Canada. So there's also maybe interesting information to find. I will put it in the notes later. Are there
just
still
for your
questions?
Information, Carlo, if I may say, I don't know if it's my system, but it's not possible to load the chat.
Okay.
But it may be my computer only, I don't know.
Yeah, I see one or two people put something in the chat, so I'm not sure if others have problems. But yeah, as always, you can raise your hand and ask your question like that. And we will share the email address of the speakers if they want, of course, so that questions can be sent also directly if needed.
My details are in the presentation.
Yeah, very
thank
good.
you
So
for
thank you.
thank you for having me.
Yeah, thank you, Annick, for the nice presentation. Then we move over to our second presentation. We go to Adam Barrowy. He is a very experienced speaker in the topic of fire safety, a lot of experience in experimental testing. He works at UL Research Institutes and the Fire Safety Research Institute. I'm very happy that Adam joined. He is from the US, but as far as I remember, he is in Singapore now, so it's already a bit late in the evening for him. So very thankful that he will give his presentation, and he will talk about bringing these electric bicycles, scooters onto a train into public transport, and he will present a bit on the impact of fires in these conditions. Adam, the floor is yours.
Okay, yeah. Thank you, Carlo. Yes, you're right. I am in Singapore, actually working on e-mobility research experiments, a little bit with Singapore Civil Defense Force, and some other battery safety things. So, yeah, I appreciate you creating the opportunity for us to share the work. Can you see my screen? And I'll go to presenter mode.
Screen. It's not yet in full screen. Yeah, now it is.
Okay. Oh, great. And I saw from the attendance that some friends that were in Portugal are for the SOP event are in attendance. So maybe you can kick back and relax a little bit. This is largely the same presentation I did there. So yes, we in 2024 conducted some e-mobility fire experiments on a intercity passenger rail car, and wanted to understand available safe time for egress and required safe time for egress a little bit better. So we had this unique opportunity, and yes, it's kind of coming out now. We ran it in 2024. There's been kind of some hand wringing with the executives in charge of allowing this out. So I've been able to share it, but the report should be out in the second week of May. So fairly confident that's the timeline now. So if, of course, this is recorded, but the report will maybe be citable. So I work for FSRI, the Fire Safety Research Institute. This is our mission, but I really want to focus on the content of the presentation. I manage the Battery Fire Safety Group, and we also have some other groups that are producing some excellent work. So if these topics, firefighter health and safety, fire modeling, wild and urban interface, or data science, specifically National Emergency Response Information System, are of interest to you, I'd be happy to get you in contact with the managers of those teams, or perhaps get them here for a presentation. So we have some active battery fire research areas. I'll kind of gloss over them. We've been working for some years in electric vehicles, and there's a report we have nearly drafted. I expect that to be out in the next month or two, documenting EV firefighting tactics. Obviously, this is the project I'm presenting now on rail cars. I wanted to feature just this adjacent project, which is damaged, defective, and recalled batteries. It is regulatorily complicated in the United States, but the challenge of damaged batteries is more widespread than I realized. So this is essentially what is happening in the United States when e-bike batteries are damaged. So I don't know that these are particularly e-bike batteries, but the e-bike batteries will go inside the drums. And the thought is that this material that's going to get dumped in on top, yeah, that's certainly a scooter battery there. The thought that the material that's dumped on top is going to mitigate the hazards that batteries can produce in this relatively small volume. So you can see from this video that it's not quite true. So we have a project to look into the mechanisms of effectiveness. And so we've done some scoping experiments. This one will show you that if a headspace is left, you can create an explosion hazard. So we were doing some research to determine how severe the explosion can be. And then this is with real batteries to demonstrate that actually there's some mechanics going on that I think were not recognized previously. So this drum does not contain any protective product in it. We didn't want to give anyone's product a black eye in a public presentation, but the batteries are releasing gas fast enough that the venting capacity of the drum is overwhelmed. And so you see what we see in these high-speed videos here, where actually it's an explosion just by overpressure, and then the gases inside are flammable. So the questions we're asking are, what is the intended mechanism of effectiveness of some of these fill materials, and how will it inert those gases that are ejected? I mean, there's other questions as well, but I wanted to feature it because we usually get really productive context when we share this with other fire safety professionals. So I'm kind of baiting you all to contact me later if you're interested in that, but that is a active project for us now. I'm going to skip all the rest of these and just get to the slides on e-mobility. So this is admittedly a little bit of a disclaimer. We have enough battery safety research that occasionally we are kind of accused of being anti-battery. We're absolutely not. I'm a personal enthusiast of them. So some photos of various e-bikes I've had on various trips. This was when I was visiting Tom Hessel's in NFPV. So they're excellent machines, but when I was in my hotel room, I still segregated myself from the e-bike by a door. Unfortunately, the only door was just a bathroom door. So they have some challenges, but they are mitigatable. And this presentation will share some of the recommendations we have for train cars. New York City is driving most of our concerns. This was outside near Penn Station in New York City. I had just taken a train there. I walked past and filmed some of these bikes. Almost all of these are e-bikes, and this is driven by the economy for food delivery driving and package delivery. So post-COVID, we see incredible quantities, and what happens often is, I kind of in quotes here, the most challenging component of urban mobility design is first and last mile. So those were delivery bikes, but commuters are occasionally, and with growing regularity, using e-bikes to get to the train. Then they want to take them on the train and then take them off. Our transport systems are not as efficient as Europe. We have intercity trains, but once you're off the train, it's not very convenient typically to get from the train to your next destination. So that is a fairly significant challenge in North America. So we wanted to first kind of cover what is the impact of e-mobility on residential fire timelines. This is an area where we've seen, of course, lots of impact. We have an old paper that we delivered on the legacy fire timeline, so how long it took fires to develop in the houses of yesterday with organic materials, and the modern fire timeline with plastics. So this gets modified when we think about e-bikes. So this kind of is a just a something to benchmark in your mind. The couch of yesterday, maybe something your grandmother had, and then this is the couch of today. And this is just to set an expectation. These fires are fast moving. So this particular synthetic couch will reach 3 megawatts within about 500 seconds. You can see it's because the fuel is melting and the surface area is increasing pretty rapidly. So yeah, actually in about 250 seconds, the peak of burning is done. And so we had questions about, well, how does the e-bike fire growth rate compare to what we used to say was the greatest challenge in residential occupancies, is the ignition of upholstered furniture. So you need to watch the plot on the bottom right kind of carefully, because this is sped up faster than real time, but also the fire is very fast developing. So you'll see the smoke come out, and then the e-bike ignites fairly quickly. And within about 30 seconds from ignition, the first peak is encountered at 1 megawatt, and then that 1 megawatt fire drives the involvement of the plastics of this sort of seated e-scooter. So we have another megawatt peak. So if that is now exposing an upholstered furniture fire, then we have a secondary fuel package which becomes very quickly involved. When we ran this experiment inside a small North American home, it's kind of similar to an apartment flat in terms of square meters. And this orange square is where we place the e-scooter, and then everything else in yellow here is exposed and open. There's no closed doors. This back bedroom was closed. So this is essentially why the train company reached out to us. So they had seen this video and said, well, this volume is larger than a train car. So in this case, some smoke came out. We have a fairly spectacular thermal runaway. The smoke ignites and that pressure pulse blows out the windows, which means the fire is not vent limited, and the e-bike fire spreads to the upholstered the upholstered furniture very quickly. So the fire spread, especially once the flames start to roll over the ceiling, really exacerbates fire spread. So we started getting questions around, well, train cars are smaller, they're long, they're narrow, and a lot of them have combustible surface finish inside. So even though it's fire retardant, what kind of results will we see? So for the modern fire timeline, believe it or not, it does not change too much in terms of time to collapse. Based on our estimates, it's eroding this time to flash over, which means occupants have less time than ever, like potentially less than a minute from the time of thermal runaway to escape. So I'll skip through this, but these have been kind of our benchmarks. So what is the potential impact of an EMV fire on a passenger rail in terms of fire risk? So I've already introduced the car. This is what it looks like inside. And we started the battery pack fires by heating the batteries. We chose not to overcharge them because that tends to be a even more severe fire than it would probably be likely on a train car. They're not allowed to charge any of these devices in transit. So overheating is perhaps a little bit more representative of something that's been abused and then goes into thermal runaway at a high state of charge. So we had a standing e-scooter, the folding type. They're allowed to put those in the overhead area. An e-bike, which has to go in the bicycle storage area. So for this particular train car, it is segregated from the passengers by some partitions. And then we ran 2 experiments with seated e-scooters. These are not allowed. And when we argued with this train company that we should do the test with them, the next day, their staff sent us photos of passengers riding with them. So we know this happens, even though that's not allowed. It's difficult for the train staff who needs to focus on running the train to be enforcing every single policy that they have. So it's unfortunately they may make it aboard. So the train car was instrumented mostly for us to look at tenability. We had a couple other more experimental measurements on board, but mostly what we had was thermal characterization near the e-bike, so some heat flux gauges, and then fairly evenly distributed from the near end, the middle, and the far end. We had gas samples and thermocouples. So these measurements are all really intended for us to look at the development of smoke and thermal conditions down the length of the train car, and then to be able to perform fractional effective dose calculations for asphyxiant gases and thermal fractional effective dose. So we could look at the potential for occupant incapacitation. So what you'll see when this video plays, actually, here's the photo from the train company staff, showing us, look, these things are making it on, even though we don't like it. What you'll see is that there was, actually, I have to kind of skip this step. This starts a little after sudden gas venting. So when we're heating it, there's really nothing to educate the public about, to warn them to say a thermal runaway can happen. It can be quite sudden. And so there's some gas venting. It can be kind of confusing, but it's flammable smoke, so that eventually that results in a fireball. And then we'll see smoke spread from this far end of the train car. And that, in all 4 experiments, occurred between 19 to 34 seconds. So the average is around 20, based on the repeatability of the experiments. The jets from the devices tended to overwhelm the fire retardants in the surface finishes, so the surface finishes became involved. And they're, ordinarily the assessment is that they would not for most ignition sources. These plastic ceiling panels softened and began to drop within 90 seconds, so that's going to become an egress impediment. And visibility was lost as fast as about 2 minutes. The median was about 3 minutes. So, of course, if people have not evacuated, the lack of visibility, while it's, kind of easy to understand where you are in the aisle, it is invariably going to slow egress. And these fires were actually vent limited much more quickly than we thought. So there's not much vent area on a train car. They're fairly hermetically sealed. So there's not a lot of makeup air. So here's the video. So you'll see, if you're potentially a passenger on this end of the car, that is certainly concerning, but it would be confusing too. So our worry is this fire starts, and now some of that built up flammable gas burns off, and buoyancy is now driving the smoke. So the smoke actually moves kind of quickly. And so at the far end now, every passenger within about 20 seconds in this case is being exposed to smoke. So our questions were around the available safe time for egress versus the required safe time for egress. And so there are obviously different components to required safe time of egress that we really can't control. The pre-travel time, so the amount of time it takes people to recognize that there's a hazard, the amount of time it takes for them to respond to the hazard, and then their travel time. So wherever they are in this train car getting to an exit. And we'd like to see margin. Our concern is that the real available egress time is actually quite short because of the development of untenable conditions. So that's really what we were analyzing. I'm sorry, we were actually developing the available safe time for egress. So when we looked into literature to understand the published required safe egress times, there really is not much for mass transit. It's unfortunate. And so what we saw is if a rail car was stopped at a level platform, so there are 2 exits available, one at either end of the rail car, and there's no change in elevation, so the footing is confident and good, and there's very little gaps. The ideal egress time is about 1 minute and 40 seconds. Less than ideal would be the train is perhaps stopped, and it's on what's called a right-of-way, so they have to go down a set of stairs now and then step onto unsteady footing like gravel rocks kind of thing. That was documented as taking a little more than 4 minutes. An actual evacuation is likely going to be much slower, especially if the train is in transit. So once the train starts to stop, even with emergency stops, the stops are not all that quick. So probably the passengers will try to evacuate to neighboring cars through the doors. So these numbers, unfortunately, don't take into account things like smoke, behaviors like people looking to get their family members together or grab their belongings. So there are many factors that would extend these times and make actual evacuation much slower. So when we looked at the fractional effective dose calculations, we chose a threshold of 0.3 because that would be fatal to approximately 11% of the population. And our concern was, since there's limited means of egress, especially imagine in the first or last car, then someone that becomes incapacitated becomes an impediment to other passengers egressing. So with that metric, we found between 3.5 and 7 minutes across the devices to achieve a fractional effective dose of 0.3. So of course you can compare these times and see there are some overlaps. Thermal fractional effective dose, fortunately, is not too severe. The areas near the e-bike could potentially incapacitate someone from burns, but generally the global temperature conditions down the length of the rail car were not nearly as threatening as the asphyxiant gas concentrations. So have we come close to this yet? I think this is the real concern and why there's so much pressure, and there's been some passionate debates for getting the report out as quickly as possible, because we have seen incidents where there have been e-mobility devices that have gone into thermal runaway on the train platforms. Here's actually an incident that occurred in Toronto. There's a bit better video that's been released publicly now. But this was, well, the train was stopped at a station. You can kind of look in and see the device burning and the gas concentration. Someone, of course, goes back for their bag, naturally. And so there's been close calls. And this is why in the US we have a saying called "only in New York." This is an e-mobility device, must have a low state of charge, so someone likely threw it down in frustration, and everyone is either Instagramming it or maybe waving a napkin in front of their face because the smoke is uncomfortable. But unfortunately, none of these people move. So we have a real public safety education issue to resolve here. In Madrid, one of the fires progressed to a greater level of damage, but fortunately no one was hurt. And so one of the challenges is most policies address frequency. So they're around saying things like you need UL certification, which is certainly good, but the consequences, I think, need a little bit better mitigation as well. So our conclusions, I already kind of given you these for residential, so let me get to railcar. EMV, we say electric mobility vehicles as our nomenclature. The fires develop faster than many passengers can evacuate safely. That is going to be especially true if the train car's moving or stops in a very inconvenient place like a tunnel. The fire can slow egress as compared to published RSET data. So we really do need better RSET data to understand how long it would take people to evacuate. I mean, I think we can already conclude that the required safe time is greater than the available safe time. So already we have motivation to request, changes to policies, maybe changes to the engineering of the train cars, and to do better public education. So we also have issued guidance through Take Charge of Battery Safety. That's our own public safety education material. We're putting, we have another large government grant, about $1.5 million, to continue this work, and we want to adapt it to things like college dormitories and the ridership of passenger mass transit applications. So that QR code will take you to the webpage, or you can go to batteryfiresafety.org. That was predominantly based around our residential research, but it's being updated over time here for these new other scenarios. I'll skip the video for that too. I would like to plug this really quickly back to residential, just briefly to say that we reran that video that I showed you, reran the experiment, and just put in simple residential sprinklers compliant with our North American residential sprinkler fire standard. And although it's low flow, and although the jet that you saw impinge on the ceiling reoccurred in this case and activated all 4 sprinkler heads nearby, even though the system was pretty challenged, it was still enough water flow to keep this fire in check and prevent spread to the adjacent upholstered furniture. So the recommendations we have for passenger rail cars would be starting with the most simple, the most cheap, and most readily adoptable is not allowing any electric mobility vehicles in the first and last car. And that is all based around this potential that Even a fairly small EMV fire may compromise the confidence of passengers to egress past them. So it may block them from the exit. And the regulations we have, they're federal regulations that determine the surface finish. Sorry, it's been a long day. Flammability. They don't use an ignition source as strong as a battery fire. So it is likely that the battery fire can cause fire spread to the surface finish materials in the upholstered seats. So we recommend restricting size. This carrier we worked with does that, so we said continue. Eventually, at some point, the battery is just unreasonably large. To require battery safety certifications, we've taken the UL out of this because there are international certifications that any certification is certainly better than no certification. For the rail carrier staff, we have said no firefighting. And the concern was that someone could be injured or killed trying to extinguish an e-mobility fire. And that has now happened, unfortunately, in the United States, just a couple weeks ago. So we've seen that the extinguisher is not effective and they died, likely of smoke asphyxiation, because they stayed too long in the environment. So for passengers, we recommend self-certification. It's limited. It's what the airlines do to us all now to say you acknowledge that you have no hazardous batteries that are going to go in the belly of the plane. Certainly, we would say ask the passengers to comply with the policies. We would like to see separation of people and electric mobility vehicles, like the kind of storage area that I showed you for the e-bike, but hopefully maybe more like a dedicated compartment, maybe even dedicating some part of the back rail car. Some rail carriers I have heard out in other countries are doing that. And then to prepare regional first responders for the incident potential. I don't like saying mass casualty. It doesn't mean mass fatality, but if 80 some people are exposed to battery smoke, that is likely much more than a single ambulance can handle. So we are recommending the rail carriers to provide awareness to their first responders. This is a bit of a recycled slide here too, but where risk is the likelihood of an event occurring times the consequences or severity of it. We've put together some lists of things that can be done to reduce both the frequency and the severity of the incidents. So I hope I stayed within time. Thank you for your time and attention. I've got however long Carlo wants to do for questions.
Yeah, very, very good presentation. Thank you, Adam. Very insightful. A bit worrying also. So I can imagine that people do want to see the report and read it. And at a certain point, we have to start thinking about measures to increase, what you just all explained. Yeah, it's it's very interesting. First, I have a few questions myself, but I want to give the audience the chance first to raise questions if they want. Please raise your hand if you have one. Yeah, Annick, I see you're the first one. Yeah, feel free.
Yeah, thank you. I was just wondering, we have a lot of problems in Europe. There is a lot of legislation in place, a lot more, I think, than in other continents. But what we see is that there are huge numbers of vehicles coming from outside Europe, used to just not comply with legislation. And there is really an issue of surveillance or lack of surveillance. So what is your view on that? Would that be something that would be helpful, and that would be helpful to minimize the risks of fires on trains, to have surveillance on products that are coming from outside markets to see if they comply with legislation? Because we feel that those who are complying are being punished. They do all the hard work and they incur the costs. And then you've got free riders who just throw on the market whatever they want.
Yes. So, I think, I guess to put it one way, Unfortunately, I don't think that problem can be resolved in the train car. For us in the United States, what we're talking about is pushing our federal government to pass a bill. We actually have a couple bills that have gone to our government, and because our politics are not moving quickly at the moment, they have not really gone anywhere. And those bills are aimed at making sure the devices that come in that could be used would be safer. Unfortunately, what we learned with COVID in talking to our rail carriers is that although the train conductors can be very intimidating people sometimes, when they were asking people to be compliant with masking policies, sometimes they were being physically assaulted. So they do not have the appetite to be trained police. There are some of those, but there are not enough of them. And so we think that it's a fairly porous defense to say, put all the responsibility on train staff who would say, I'm sorry, you cannot put this on this train. So we know that public education, some conductors may be successful, and some passengers with education may see that reduced. I just think, unfortunately, our research is not enough to eliminate that challenge. So it needs to come from elsewhere as well. Standardization for e-mobility devices and probably national regulations.
Yeah, it's a valid point that we try to develop safe products so that the frequency of these events is much lower, or in the future does not happen that much. Of course, an incident can always happen, and then we are in the situation that you just showed. It's food for thought. I think your report and all the insights will have an impact on all public transport operators in the future to see how to deal with these vehicles. You didn't say in your recommendation to not take them on board anymore, but look for solutions which are feasible, compartments, putting the vehicles in another space than the people. It all has a logistic impact, of course, but it increases safety a lot, I can imagine. So,
yeah, I mean, honestly, I think all we've really done is put some data and visuals to a problem probably many people in this call have even worried was possible. So we kind of, okay, the presentation is timely, but I think many of us were already thinking about this. So yeah, I mean, it's yeah.
There's maybe one question I still have. You say public education and the risks, if we see flames and fire, people get worried. But the first degassing and the gases you see, I think we underestimate a lot the risks, the toxicity of the gases and the impact on your health. Like you showed in the New York video, people just stay around that burning vehicle, which is worrying. I would not stay there.
Yeah, and we have heavily targeted New York, but when we ran a focus group there as part of our Take Charge campaign, only about 20% of we kind of randomly selected strangers off the street. Only about 20% were aware of the issues they were having. I showed some statistics from New York City briefly, and they were having hundreds of e-mobility fires, structure fires per year, with double-digit deaths in some cases in the overall year. So if any populace should know of it best, it's New York. But unfortunately, I think as fire safety practitioners, we think the rest of the world understands that fire is as risky as we see it. And that's just unfortunately not the case.
Okay. I see one hand is raised by Ben Koo. And in the meantime, I will also check the questions in the chat briefly. But Ben, feel free to ask your question.
Thank you very much, Adam. I understand that the report for this study will be published soon, but I'm wondering if the report for e-bikes or scooter fire in residential apartment or houses has been published, or is it available to view somewhere?
Yes, actually. So I don't have a quick link for you, so you'll have to dig around a little bit on fsri.org. but we have 2 journal articles that went through, I think both went through fire technology. Charlie Fleshman was the lead author on those, but we did documentation of the conditions inside that residential structure, and then we went back and wrote another about the effectiveness of residential sprinklers. So those are both available.
Thank you very much.
Okay, thank you. There are 2 other questions in the chat. I will take one very quick, and then we also have to move over to the next presentation for time reasons. Can you share the federal regulations that are being considered, and also do they include buses too instead of only train?
So the federal regulations, they're not regulations yet. They're bills that have been proposed. Both were bipartisan bills, so members of Congress put their heads together on both sides. They still do that sometimes, and they put them forward to the Senate, but it hasn't gone for a vote. I always forget the names. I think one is like the Making Lithium-Ion Batteries Safer Act, and the other one I can't recall. But they have formal bill numbers. If you email me, I can pull that number up for you.
Okay, thank you. Yeah, I see my next speaker also has a time limit, so I suggest, Adam, thank you very much for your time and presentation. If more questions pop in, we will take them offline, and you can also skip the rest of the webinar if you want, if it's very late.
Sure. So, thank you very much. I appreciate the opportunity, and thank you for everyone's time and attention.
Thank you very much. Then we move over to Ruud van Liemt from NIPV in the Netherlands. In fact, his presentation links very well to the topic of Adam. Ruud works for NIPV. They also did a lot of experimental testing of bicycles, electric bicycles and other bicycles in the parking lots at railway stations. So instead of taking the bike on the train, now we will have a look at what happens if we store 1,000 or a few hundred of bicycles in a parking lot. So Ruud, the floor is yours. You can take over the screen. Yeah, the presentation is there.
Yes, thank you, Carlo, and thank you for having me here today. As Adam mentioned, in the Netherlands, we like to ride bikes, and most of the times, instead of parking them in our bathroom, we park them in bike parking facilities like the one you see here on the picture. We did conduct research for ProRail, which is the organization which is responsible for the railway infrastructure in the Netherlands. And part of the railway infrastructure is a lot of bike parking facilities. And the issue there is, well, we used to have bikes which are mainly steel, and there's a fairly low risk regarding fire in these bike parking facilities. But with more and more e-bikes within these facilities, there were some questions about, well, is there any additional risk? Do we need to take any additional fire safety measures? We did a literature research, and we found out that there was not that much knowledge available, let's say, regarding a bike on fire. And there was literally no research available with a bike on fire in a bike parking facility. So for that reasons, we did some fire experiments, and that's what I'm going to talk to you about today, and also a little about the translation to, let's say, determining the fire safety measures for these bike parking facilities. As a start, a few things about NIPV. We are a government organization, and we focus on crisis management and the fire service. We did this research in 3 phases. We started up with some, let's say, small scale experiments with 1 bike or scooter at a time underneath a calorimeter, and we measured things like heat release rate, the yields of gases, and also the possibility a fire will spread to another object in an, let's say, hypothetical bike stand. So we knew where other bikes would be, and we measured things like radiation in order to determine if a fire would spread to another bike in a parking facility. Based on these results, we conducted phase 2. In phase 1, we did see, well, a fire could spread to other objects. Then in phase 2, we built a part of a bike stand, and we looked at the progression of fire in this stand. We did know, well, there's quite a possibility a fire will go to another bike, but how fast will all these bikes be involved in the fire? We measure temperatures, and also will the fire, is it possible a fire will spread to other rows of bikes? So the fire will jump over an aisle. And with the knowledge of phase 1 and phase 2, and also additional knowledge of in literature, we started phase 3 to determine which fire safety measures are needed in the bike parking facilities of ProRail. This will really depend on the fire safety goals ProRail has for their different parking facilities. There's quite a big variety of parking facilities. We'll talk about that later. And it's also a risk-based decision, but I don't think I need to explain that to you. A little bit about the roles and responsibilities. ProRail is the owner of the bicycle parkings and also the commissioner for this research. NAPV set up the framework for the fire experiments. Well, let's say we designed which test data we needed. We also did the data analysis, and Peuts did organize the experiments itself. They designed the test setup, selection of measurement equipment, and also the protocol during the tests. Short summary of phase 1. Not the most interesting part if you like a fire like me, so it's only small. So we're gonna go over that really briefly. We did, let me do a short calculation, 8 and 7, 15 tests, 8 with bikes and 7 with scooters. We ignited all of them with an external fire nearby the battery, and for the non-electric bikes or the gasoline-powered scooters, we used the worst case position. So we start off with 3 non-electric bikes with a variety of accessories. So let's say a child seat, 5 electric bikes, and the variables there were the location of the battery, 1 or 2 batteries, and also the accessories. Most of the bikes had a 500 watt-hour battery, and we tested every time with a 100% state of charge. Then the scooters, 1 gasoline-powered scooter, as sort of a baseline with a full tank of gasoline, and 6 different types of electric. Well, it says bikes here, but it should be scooters. Sorry for that. And the test data, we already mentioned that, and an important part here was, will the fire spread to other objects based on radiation, but also ejecting battery cells. Short video how this type of test looks like, and some of the effects we saw. So you see the jet flames ejecting battery cells, and we also looked at the time a cell will burn after it's ejected, and sometimes it was for more than 10 seconds. So that could be enough to also spread a fire to another object.
Mhm.
When you look at some photos after the experiments, you can see a few things. Starting on the left, you can see that, well, most of the times only a part of the bike is burnt away. So the front of this bike on the left is actually still looking like it was in the shop when we bought it. So depending on the location of the battery, most often the back part of the bike burns away or the front part. And looking at the top right, you can see the steel frame tubes just completely burn through. That was something I did not expect. And it means that it was a quite intense fire with quite high temperatures. Then a little bit of the data we gathered. You see here on the 6 different bikes, all of them the same type. The only difference is having accessories or not and having a battery or not. So starting with a non-electric bicycle without accessories, it had a peak heat release rate of 60 kilowatts. And we didn't expect fire propagation due to other bikes in a bike stand. With the same bike, but then with a child seat on the back of the bike, you can see a quite high increase in peak heat release rate. It's more than 4 times the peak heat release rate without accessories. And in this case, we would expect fire propagation to other bikes in the bike stand. And actually, when you compare this non-electric bike with a child seat with an electric bike without accessories, you can see that the peak heat release rate for the non-electric bike with a child seat is higher than that of the electric bike without accessories. And with this electric bike without accessories, it was kind of a gray area. Well, would the fire spread or propagate to other bikes in the bike stand or not? But with a pannier or a child seat, you can see again a quite high addition of the peak heat release rate. And here you can see, well, we really did expect the fire to propagate to other bikes. And there's one thing to remember here for a later video in the presentation. Based on the measurements of the radiation, we did some calculations that the electric bike with the child seat, the fire would propagate to the left and right in 8 minutes, and to the bike in the upper level in about 2.5 minutes. And we tested this situation in phase 2, so we could, let's say, validate our calculations we did. So you can see if I did any decent calculations. Just a short video from a scooter. Well, you can see it burns quite a bit more intense than the bikes. There was quite a variety in the different types of scooters, different type of batteries in, let's say, the effects we saw, the fire effects. Did we see ejecting battery cells? Did we see jet flames or not? There was quite a big difference in the different scooters we burned. Looking at the aftermath, well, it's entirely different than the situation with the bikes. With the bikes, only a part of the bike burned away. With the scooters, everything that was able to burned away. I'm not going to show you all of the data, but there wasn't, well, let's say in terms of peak heat release rate and the total energy release, that there wasn't, let's say, an additional risk compared to the gasoline powered scooter. Of course, the fire effects are different. So they both burn quite well. Then stepping over to the phase 2 with the parking configurations, which I think is most interesting. You see a little bit more bigger flames. We did 5 experiments, 2 with bikes, 1 without and 1 with a sprinkler. Fat bikes, we actually did 2 types of sprinkler. And also without a sprinkler, and scooters, because of the intensity of the burning, we knew, well, if you want to have any, let's say, reasonable package of fire safety measures, you're gonna need to have any sprinkler or some sort. So we only tested that with a sprinkler. First up, bikes without a sprinkler. We had a fully occupied stand, 7 bikes in a row, 2 layers on top of each other and 2 rows next to each other. So in total 28 bikes. The bottom layer is all electric and the upper layer is non-electric, which is most likely the way people will put their bikes in a bike stand. The electric bikes are a little bit more heavier, so they are not placed that often in the upper layer. We ignited the fire at the electric bike with a bike seat, child seat in the middle of the right row over here. And ProWheel likes me to say that the current situation they have is like 5 to 20% electric bikes. So the real world situation is different than the video I'm gonna show you. And remember again, my calculations predicted fire propagation to the left and right side at 8 minutes and to the upper bike in 2.5 minutes. In this video, you can see the left row on the left side in 2 different views and the right row on the right side. And we start here at 0 seconds at the ignition time. The video will be speed up in a few seconds. So in the beginning, because of the external ignition, it's mainly the battery package that burns, the child seat that burns, and the, let's say, visible thermal runaway effects on the outside of the battery. It's 5-6 minutes sometimes, so it takes some time. And in this experiment, we noticed that until about 8 minutes, only one bike burned. And you can see some pyrolysis, the left and the right side. And at this point, the bike on top of the first ignited bike is also burning. So until 8 minutes, one bike burning. This was a gas spring in the top layer that exploded. What you see now, the upper layer is quite close to the ceiling, and you see some horizontal flames nearby the ceiling, which ignite the seats of the bike. You can see burning droplets from plastic parts, which ignite the bottom layer. And now it goes really fast. After 8 minutes, we had one bike. After 10 minutes, there was a full row on fire. So there was 14 bikes. And you can also already see on the left top part, the fire propagating to the other row of bikes. This is quite an intense fire. And after 12 minutes, all 28 bikes in this experiment was on fire. The cameras didn't like it. The measurement equipment didn't like it. And actually, this experiment was the experiment we thought was gonna have, let's say, a fairly slow fire propagation. In a case where after 30 minutes or so, the fire department would have a good probability of putting out the fire. But actually, because you have 2 layers on top, ceiling really close to the upper layer, the fire propagated much faster than we expected. Afterwards, it looked like this. Not only did everything on the bikes that could burn burned away, but also the ceiling made from Promatect plates also was damaged a lot. It needed to be replaced. It had cracks in it. So that means that the fire was really intense. And maybe good to mention is that there was quite a lot of ventilation possibilities. So there was some open doors on the front. So the fire was probably still quite oxygen fuel controlled. We also did the same test with the sprinkler. Part of the ceiling was replaced, and this black part, there's also a ceiling, but it wasn't replaced. But it's good to mention that there is a ceiling there. Otherwise, the sprinkler head over here would be not under a ceiling, but it is under a ceiling. Again, a fully occupied stand with 28 bikes, and all of them were electric. We had a lot of accessories on them. So 6 had a child seat, 8 had a pannier, and it was almost impossible to get them all inside the bike stand without pushing another bike outwards on the other row. So they're really close together. I don't think it could be more worst case than this. And also for the sprinkler, we didn't have a free height of, let's say, 20 centimeters from the bottom of the sprinkler head to the top part of the bikes, and the bikes were really an obstruction for the sprinkler head, so it was not up to code. But we did wanted to know, well, will it function properly? I don't have time to show you all the videos, but this is a video afterwards. So this is the left row, which was entirely undamaged. And this is the right row, where you can still see quite a lot of damage. But when you analyze the video and the data, you can see that after the sprinkler was activated, the fire didn't propagate any further. So you can see the bikes on the outside of the row, they are still quite undamaged, and the fire didn't propagate towards these bikes, and that's all thanks to the sprinkler. The sprinkler suppressed the fire actually in about 30 minutes, completely put it out, only with one sprinkler head activated. Fat bikes, we also did a test with them, 10 in a row. They had 2 batteries of 750 watt hours, 50 centimeters apart, and we ignited both batteries at the same time. Looking at the pictures afterwards, well, you can see they burn quite well, but actually it was a entirely different fire than the bike experiment. It was more of a, let's say, an additional fat bike got involved in the fire in about every 1.5 minutes. So there wasn't a real, let's say, quadratic increase in the fire size. It was quite a linear increase in the fire size. We did this with the sprinkler, and this again looks quite different. So there was one bike that burned away quite a bit, 2 other bikes that were damaged, and all the other bikes, well, I think you can ride them home if you would want to. Maybe clean them a little, and then you can use them again. Scooters, we did 7 scooters in a row and 2 rows next to each other. We had a little debate: do we need to ignite them at the gasoline scooter or at the e-scooter? And there was there's a discussion about sprinklers being effective on a gasoline pool fire. So we decided to ignite the experiment at the gasoline scooter. We did at a pool fire, and the sprinkler was, well, good at containing it. You can see the results of these scooter tests with the sprinkler. One scooter, the gasoline scooter, burned away quite a lot. The adjacent scooters on the left and the right side had a bit of damage, but I think in about 10 or 20 seconds after the sprinkler head was activated, they were put out immediately. So the overall results, the bicycle, they really showed an unexpectedly rapid fire development. The fire could also spread to other rows. So in the end, it could grow and propagate to the entire bike parking facilities. At ProRail, a bike parking facility could be for about 10,000 bikes. So it could be quite a big parking facility. With the fat bikes, it was a little bit more a linear fire propagation. About every 1.5 minutes, an additional fat bike became involved. With our test setup, based on heat radiation, we didn't expect a fire to propagate to another row. But the battery cells igniting, ejecting on fire could be a factor in that. We measured temperatures over 1200 degrees centigrade, so quite high, and a lot higher than the standard temperature time curve we use in the ISO 834 for testing our, let's say, the constructions and better compartmentation building components. The sprinkler was effective in actually every situation that we tested, and we did see that the gas springs eject forcefully, so that's another thing we need to look at. And with the experimental results from phase 1 and phase 2, we did give an advice to ProRail which fire safety measures could be useful, and a few considerations and also an outcome to consider before we talk about the measurements, the measures. The fire that starts with a thermal runaway will be different than the external ignition that we've seen in our experiments. So the start of the fire might be a little bit different. That's something to consider. For ProRail, it's not an everyday incident. So it's a very low probability that you will have a fire, and you need to take that into consideration with your risk-based decision. And they have a broad range of bike parking facilities. They could be outside in the open air. They could be outside with a ceiling on top of it, but they also could be underneath a railway station. And then when you have a fire, it might impact on your building construction, and it could take months to before your construction will be ready to use again, when your railway structure or your train station or your rail track is built on top of that. You might not be able to use that also for months. Same thing goes for utility service, electric cables, everything that sewage system. A lot of those things are always going through the bike parking facilities when that's located in the basement under the train station. When that's the case, those things can burn away as well. And with parking garages, we've seen that it can take up to 6 months in order to restore all of that. So in terms of continuity of operations, that can be a big issue. And then in terms of possible outcomes, it really depends on the situation you have. Is the bike stand completely occupied, or are there really a lot of empty spaces? Will the fire start with a non-electric bike, or will the fire start with an electric bike with a child seat? What types of bikes are around the bikes that ignite first? So the expected fire size can vary from one bike to even beyond the bike parking facility. So that's also a thing to consider in your risk-based decision. We advise a few fire safety strategies which can be used sometimes in combination, and you don't always have to implement all of the fire safety measures here. So some things with fire prevention, prevent the fire ignition. You could say, well, we don't have any loading of batteries in our bike parking facilities. You can place levs outside. And also some things regarding fire safe behavior. Then the second strategy is based on limiting the fire size. You could train your internal staff, but as Adam mentioned, internal staff putting out a fire isn't really a possible situation, I think. You could try to detect a fire fast and have the fire department be there on time, really prepare for the fire suppression by the fire department, but that could also take in some situations too long of a time. So that doesn't work in every fire you will have. Sprinkler is a good option, which is very likely to succeed and really limits your fire size, cools your construction, helps in almost every fire safety goal ProRail could have. Compartmentation could be an option. So when you have a fire, you only have a part of the bike parking facility that will burn away. But also for the, let's say, bike parking facilities that are not underneath a train station, it could be a feasible option to just accept that there will be a burnout, but just limit the effects. And you could, let's say, fireproof the utility service or the building structural elements. And you could also prepare for alternative solutions, for instance, temporary emergency parking. This is the summary of the fire safety strategies and the measurements, fire safety measures we advise at ProRail. Additional information can be found here. We already did, let's say, a 2-hour presentation of our research, and we made a video registration from that. It's subtitled in English. And also there are some videos from the experiment. So the ones you didn't get to see today, you can find them here. And also we put out 3 research reports, which unfortunately are only in Dutch, but there are a lot of tools which can help you translate them. So far, unfortunately, I don't really have time to take up any questions. I really have to leave, but maybe Carlo can, well,
we can
send them to me afterwards, and then I will answer them.
Yeah, I know we have a time constraint, so many thanks for giving the presentation. There was one question in the chat. Are you going to share the slides and videos? So I think the slides would be shared as PDF. Videos, you share the link so people can find the videos too, which is very insightful. I took away that, I was a bit, the sprinklers, that they have such a good effect. That was nice to see. That's a takeaway from my side. And as mentioned, all other questions, if people have questions, you can mail me. I collect them and I will take contact with Ruud to come back to you. So many thanks, Ruud, for your time, and see you next time.
Thank you.
Good.
Bye-bye.
Thanks. Yeah, so looking at the time, we move over to the last presentation. It's a shorter one. It's foreseen for 10-15 minutes, but we talked a lot about the risks of the electric bicycles on the train, in the parking lot at the railway station. Now we have a presentation from the company Luxer in Belgium, given by René Pillen, and it's more about how do we safely charge and store these type of batteries in cabinets. So they have a dedicated product for that. And I will give the floor to Loxer to explain a bit what type of products they have, how are they tested, and what can you expect from them. So René, the floor is yours.
Hello, good afternoon. Can you hear us very well or not?
It's fine.
Yeah?
Yes.
Okay, very good. Thank you. Thank you for having the time to give you a small presentation about Loxer and the product that we created, especially for the safe charging and loading of lithium-ion batteries. With the booming e-bikes and the use on the rising battery fire incidents, we created a safe charging and storage cabinet. And we are with Loxer. Our main office is in Belgium, but we have also our partners in the UK, the Netherlands, France, Poland, Iberica, and Germany. And we have been founded 3 years ago, and we only look to the storage of lithium-ion batteries. What we have done with Loxer is we created an innovative solution for a modern problem. And the modern problem that we see on today with the low EVs is the uncontrolled charging. For example, in offices, people take their batteries and charge the batteries on their desk so that they can go back at home with a full battery. We see the 24/7 charging and unsupervised batteries. For example, it's a rental company. They charge 24/7 the e-bike batteries. They have batteries which can be damaged because they have been used a lot. They don't know what the customer has done with those batteries, and they charge it unsupervised. We also see, for example, this is a scooter shop. They have the lithium-ion batteries, also unorganized. They don't know where the batteries are laying, and they also don't know if these batteries are damaged or not. So the modern problem that we see is that the batteries are getting stronger. There is a low volume it's a low volume with a lot of energy. We see them more and more in use. If people buy a new bike, it's mostly an e-bike. And we see them also more and more on the street. For example, the pictures that we saw from Adam in New York, all the pictures. We also see the uncontrolled charging. People arrive in the office, they take the battery out, they charge it on their desk. Or also in apartments, people charge their e-bike batteries. And also we see the damaged batteries. People are not aware of the danger from a battery. So we have to make them aware from the danger. I don't go into this because I think most of the people here are aware from the danger from batteries. But what we have done with Loxer is we created a special cabinet only for the safe charging and loading of lithium-ion batteries. Why a special cabinet? Because lithium-ion batteries can fall and enter in a thermal runaway, causing self-fuel fires, extreme heat, toxic smoke, and even explosions. In tests and e-bike battery fires, we see a lot of flames and overpressure, like the videos that we saw from the last presentations. What we have seen is that the standard fire-safe cabinets, so the EN 14470 cabinets, which are made especially for flammable cabinets, are designed to protect the contents from the exterior fire for 90 minutes, but these are sealed boxes. If we saw the videos from Adam, for example, a lithium battery can ignite a lot of energy, and those sealed batteries, those sealed cabinets don't relieve the pressure, so there is a lot of pressure built in those cabinets, and it can create a real bomb. So that's why we changed those cabinets. What we have done with our cabinet is we want to contain the fire and we want to relieve the pressure and the vent and the smoke. So Loxer and Pierce Engineers cabinets, we created a fire-resistant construction with our construction as fire-rated. And the moment that we have the explosion, that we have the heat of the battery and the energy, we have a pressure relief on top of the cabinet, so the energy can go out, but we keep the fire in the cabinet. So we have done tests with the cabinets, the VDMA test, which is a German norm, and there we saw that we had temperatures from 1100 degrees inside of the cabinet, but the outside didn't went up. What we also made in our cabinet is that we always work with self-closing doors and an alarm. So if something would happen in a cabinet, we know already that something is happening. We have a double check, so we check on smoke and also on heat. So we work with a pre-alarm and an alarm. So if it's only smoke, you're already detected that something can help that something is happening in the cabinet. So you are aware of the fire in the cabinet. And also, we did a lot of tests. There we saw that we need a pressure relief venting. So it's not a pass-through, but a pressure relief. So unlike sealed boxes, cabinets include overpressure release valves, and that's also how we can contain a fire in our cabinet. Then we have the early fire detection and suppression. So the moment that we detect a fire, we give an alarm. We can connect our cabinets to an existing fire panel of the building. So we are aware that something has happened. And our cabinets, we tested with the VDMA protocol. So that's a new norm. It's a German norm. And this is the picture. This was the result that we had with 9 kilowatt of battery explosion in that cabinet. The last test that we have done was with 17 kilowatt of batteries. And we passed those tests, which says that the doors stayed closed during the fire. The external temperature stayed stable, so we kept the fire inside, but also the outside, the temperature then went up. And because we have the overpressure valve on top of the cabinet, the energy can go out, but the flames stay inside. This is a bit how the cabinet works and how we can contain those fires. Where do we use those cabinets, or where can we place them? We see that there is a rapid market growth. So we see if people buy a bike, it's mostly an e-bike. So we have seen a growth of four times the growth from 2090 to 2022, because we have more and more e-bike batteries in our daily life. We see, for example, from UK fire brigades that they face now 3 lithium fires a day. Where do we offer those cabinets? As for public and commercial bike parkings, that's where we promote people to come to work with an e-bike. So as a company, you offer your employees to charge your batteries on a safe way. We also deliver our cabinets to industries and logistics because they use tablets, walkie-talkies, drones. That's also something that you can charge on a safe way in our cabinet. We have the government and municipals who invest in the cabinets because they work with green service tools, and then property managers and employees. That's mostly for the e-bike industry, where you can charge them on a safe way. For us, we see that the niche is emerging, but growing fast. A few specialized suppliers offer now solutions that's tested via the new German standard. And for us, it's very interesting because now there is a way of testing, which was for us very difficult in the past, because we wanted to create a product for the safe charging and loading of batteries. But because there was no test protocol, every supplier gave another test, did another test. So now with the VDMA, it's one way of testing. Sometimes, for example, with Vito, we test smaller units also with the VDMA protocol, but then we don't test them in big laboratoriums, but then we are sure that also our smaller products or prototypes are also conform the VDMA tests.
Hello. I'll take over from René to highlight some more points concerning our key challenges. So basically, for us specifically in this niche market, there's a few key challenges. So despite the clear benefits of our solutions and similar solutions that are produced by competitors, there are still a few challenges that hinder the widespread adoption and development of safe battery cabinet solutions. Mainly, so we notice that user awareness and risk perception is difficult to manage. So many users underestimate the battery fire risk, and on the other hand, some overestimate it. So we see there that there's a clear need for education and guidelines on how to safely charge these batteries, and demonstrations and fire tests, like shown before by previous speakers, help show that cabinets or similar solutions can contain worst case incidents, so that can build some trust. We also see that currently there's some market fragmentation. So there's multiple players that offer different kinds of safe cabinets, like René mentioned, that have different purposes but are repurposed as being safe for batteries as well. This might confuse buyers and end users, so that clearly states a need for a standardized certification. And for us, the VDMA, the German industry standard, is a start, but a broad recognition is key, not only for Belgium, but also if you look at it from a European perspective or a global perspective, there's a clear need for clear standardized certification guidelines. And that loops into the regulatory uncertainty that we as a commercial entity encounter. So the regulations specifically addressing lithium-ion battery storage differ per country or are non-existent, at least to my most recent knowledge. So this niche often falls into a gray area between electrical safety on one hand and fire codes on the other hand. So again, this states a clear need for a clear and a harmonized code so that the requirements are known for the commercial entities, and investments have a long-term validity across markets and across countries and across borders, basically. So that was concerning our key challenges that we encounter. I would like to point out the value also of the research industry collaboration, shortly mentioned by René earlier. So the joint testing and development is one of the key factors that can contribute to creating new and innovative products. So our journey illustrates how partnerships between knowledge institutions and the commercial industry can accelerate this progress by jointly testing and developing new products. So as mentioned before, we did a few tests with Vito. We did some tests at the beginning by ourselves as well. And doing this in a controlled environment can help us verify whether or not prototypes work according to what we expect. And then recently, we've been performing these tests according to the VDMA rules and regulations, even though we cannot certify some of these products. So this provides us with priceless data. We can iterate on cabinet or product design, and based on scientific evidence rather than guesswork, we can develop new products. Working together gives us access to expertise and facilities otherwise not accessible for smaller entities. And this symbiosis can give way to better informed products for the market, not only for Luxor, but for other small companies that are looking to research and development, to invest in research and development for these kinds of products. And finally, this leads to credibility and an acceptance. So having an independent institute, not only VITO, but other research institutes as well, that can give credibility to the claim, having a working product can help the acceptance of these products to be a safe solution for safely charging and storing batteries. So in final, the collaboration can be a win-win. So it's an evidence-based policy making. So finally, for us, it's the goal is to work towards a clear and coherent regulation, not only in Belgium, but across Europe and globally as well. So currently, like I mentioned before, it's a bit of a patchwork. There's no single European, global, or even national law or standard specifically for our products. We see a patchwork of initiatives specifically for the charging and safely storing of batteries. In the Netherlands, it's the PGS 37. In Germany, like I mentioned before, it's the VDMA 24994. Then in France, there's a different working group. So there's a lot of different initiatives. This task force is also a different initiative, but it still lacks a global or a largely applicable rule or guideline for commercial companies to base their decisions on. So for us, the future outlook is harmonization. Having an EU-wide standard is on the horizon. We are also in the working group for Senelec for the standard for the European norm, which will be based on the VDMA industry, the German industry standard. And we would like to see it fully developed in 1 to 2 years and to be able to apply it across Europe. So in final, so we prefer to have legal certainty through harmonization. So ultimately, a coherent regulatory framework means that any certified safe cabinet can be used anywhere in Europe with confidence. And us as manufacturers, we won't need to have separate approvals per country. So in short, a clear EU level or global or even national standards backed by regulations for us is crucial to mainstreaming this currently niche solution. So that was in short what we are working on. I think René also added a picture of the solutions we currently have, just to give you an idea of what we are working with. So we have the locker cabinet, 12 lockers, the smaller cabinet, the large one, and the outdoor locker, all with fire safety measures included. We currently offer. So I don't know if René wants to add anything to that.
No.
Okay, then we remain open for questions.
Yeah. Okay. Thank you very much, René and Alexander, for giving us an insight in the products that you developed. It's good to see that solutions.
I now see that the camera is not on. Otherwise, I will place it. Sorry. Yeah. Okay. Sorry.
Yeah. There you are. So thanks for the insight in the products. Good to see that there are solutions on the market for the unmonitored charging and other storage solutions, let's say. You also addressed some of the challenges on testing and regulation. So that's something we take upon us in the next years to improve that. We did get a few questions in the chat. They were all related to the tests itself. I think the question from Silvano has been answered by the VDMA standard that you mentioned. And Cinzia Di Baro from Italy asked, can we see the models? So you knew the question up front. So we see a picture of all the products. That's good. They do have an extra specific question. Have you tested to external and internal fires reaching up to around 1000 degrees? Do you have some more details on that?
within the testing regulations for the VDMA test protocol, you have two versions. You can test from the inside to the outside and then from outside to the inside. We currently only focused on containing the fire, so from inside to the outside, and then temperatures reached 1,000 degrees and more, even though it wasn't continuously, but the spikes were quite high. We haven't done in the other direction, the test from the outside yet, but this is also a possibility within the current VDMA regulation. You can also test it that way, but that's to come. It's on the agenda, on the to-do list.
Okay.
For us, the main thing was to keep the fire and the heat and the smoke inside so that we can protect the outside, so the building and the places where we charge batteries, and that you can contain it.
Yeah.
Okay, that's clear. So I hope, Cynthia, that the question has been answered. Yeah, that's good.
Thumbs up.
Yeah. Checking, are there still other questions? If not, I'll thank René and Alexander again for their presentation, and I just have one slide left to close the workshop. So thanks to all the speakers for, I hope it was also an interesting program for all the participants. I think we gave a nice overview on the technical laws and regulations, and then moved into practice and experimental examples of what can happen and how to mitigate these effects. And then we ended, of course, with the cabinets and a product which helps in safe charging and storage. I hope you liked this workshop. It's not our last one. We will definitely do many others coming from Task49. And on the last slide that I want to show, I will give you a preview on the ones that you can expect in the next period. I have every 2 months a meeting with all my experts from the different countries involved in Task49. In fact, tomorrow at 3 o'clock, we have our next telco. We already discussed topics for future workshops, and this is in fact a bit the list. Maybe the order can still change a little bit, but it gives you a view on what we will focus on in the next period. Probably the next workshop will focus not on light electric vehicles, but we will change completely. We will focus on the heavy duty vehicles. All the places where you have to charge the electric buses and electric trucks. We talk about higher powers, big batteries at one location. So a lot of questions on insurance and fire emergency response guidelines are popping up. So that will definitely be also an interesting topic for our next workshop. And you can see other topics in the future. We will look at the post-crash event, how to deal with damaged electric vehicles after an incident, what's the aftercare process, the towing companies, and the storing and handling of the damaged vehicles. Parking and charging in residential or apartment buildings is another topic that we definitely want to talk about. It has specific challenges, let's say. And as you can see, we will dig into the batteries itself. We will talk a bit more about innovation projects. So the list is still long, so you can expect us in the next 2 years to pop up with many more presentations and workshops. And if you want to know all the details of these next workshops, just connect me on LinkedIn, and you will all get invites automatically via the LinkedIn posts. Okay, I think that's all from my side. I'll look around. If there are burning questions left on the task, you can still raise them. I'll put them in the chat, put them on email, and we answer them afterwards. I will prepare the recording and prepare the slide set to share with you, so you can find it in your mailbox in the next week. And I would like to thank you all for participating and hope to see you in one of our next workshops.